have another problem in Chapter 11 of Thermodynamics and Heat Transfer, Combined Conduction and Convection Heat Transfer. Problem 2. A 240 watts heater has a spherical casing of radius of 0.1 meters. The heat transfer coefficient for conduction and convection from the casing to the ambient air is obtained from a Nusselt number 55.02. The ambient temperature of the air is 35 degrees Celsius and the thermal conductivity of air is 0.02 watts per meter times Kelvin. Find the heat flux from the surface at steady state and the steady state surface temperature of the casing. So we have the given Q is equal to 240 watts, radius is equal to 0.1 meter, and the Nusselt number for convection is equal to 55.02, and the thermal conductivity of air is 0.02 watts per meter times Kelvin. So in this problem, we will find the heat flux and the surface temperature of the casing. So the heat flux from the surface is given by small letter q is equal to the q over the area. So we have q all over 4 pi r squared. So the heat flux is equal to 240 watts all over 4 pi times the radius, which is 0.1 meter square. So the heat flux from the surface at steady state is 1910 watts per square meters. Next is we will solve now the steady state surface temperature of the casing. But before solving that, we will find first the convective heat transfer coefficient by using this formula. So H is equal to the Nusselt number times the thermal conductivity all over the diameter. So we have 55.02 times the thermal conductivity, which is 0.02 watts per meter times Kelvin, all over the diameter of 0.2 meters, since our radius is 0.1. So the convective heat transfer coefficients will be 5.502 watts per square meter times Kelvin. So now we will be solving the steady state surface temperature of the casing by using this formula. So we have heat flux is equal to the convective heat transfer coefficient times the quantity of the steady state temperature minus the ambient temperature. By deriving this formula, we have steady state surface temperature is equal to the heat flux all over the convective heat transfer coefficient plus the ambient air of the casing. So we have 1910 watts per square meter over 5.502 watts per square meter times Kelvin plus the temperature of the ambient air, which is 35 degrees Celsius plus 273 to make it Kelvin. So the temperature will be 655.15 Kelvin. Subtracting it by 273 to get the temperature in degrees Celsius. So the steady state surface temperature of the casing is 382.15 degrees Celsius.